Number 21. What is the speed of an 800 kilogram car whose kinetic energy is 250 kilojoules? The information that is given, the mass of an object, which is 800 kilogram. The kinetic energy of an object is given 250 kilo means 1000 joules. And I need to find the velocity. The kinetic energy of an object is the energy of motion. So if an object has velocity and the mass, an object has kinetic energy. The formula is 1/2 mv squared. So I'm going to plug in the information that is given. The kinetic energy is given 250,000 joules, 1/2. The mass is 800 and v squared. I can divide both sides by 100, and also if I divide 8 by 2, 1/2 of 8 is 4. So I can divide by 4 both sides. Here I still have 2500 equals to v squared. Then if I take the square root of both sides, then my velocity is equal to square root of 2500 is 50, square root of 4 is 2, so the velocity is 25 meters per second. One kilogram salmon, so the mass is given 1 kilogram, hooked by a fisherman, and it swims off at 2 meters per second. So the initial velocity of the salmon is 2 meters per second. The fisherman stops the salmon, so the final velocity is going to be 0 meters per second. And it swims over the distance of 50 centimeters, which is 0.5 meters, before it stops. And they want you to find out the force needed to stop the fish. So I'm going to use the old method, the way I would solve it. So the force is equal to mass times acceleration. The acceleration is change of the velocity over the time. The time is not given. So the time is equal to the distance over the average velocity. The distance is 0.5 and the average velocity is 1. So the time is 0.5 seconds. Then the force is equal to the mass, change of the velocity, final minus initial, divided by time. So I have -2 divided by 0.5. It's the same as divided by 1/2, the same as multiplying by 2. So that gives me -4 newtons. So the force acting on the salmon is -4 newtons. This is the old way we used to solve this question. Here is the new way to solve this question by using kinetic energy. So kinetic energy of the salmon initial is 1/2 the mass and velocity squared. So that gives me 1/2 of 4, which is 2 joules. Kinetic energy final of the salmon is 1/2 the mass, and it stops, so the velocity is 0. So that is 0 joules. So I have initial, and I have final kinetic energy. Change of the kinetic energy, change of any energy, is equal to work. So whether it would be kinetic or potential energy that is changing, it's still equal to work. So in order to do work, you have formula for the work is force times the distance. So the kinetic energy final is 0 minus initial is equal to the work. But work is equal to force times the distance. So the force times the distance, which is 0.5, right? 0.5 is equal to -2. So the force in this case is equal to, again, -2 divided by 0.5, -4 newtons. And in this case, I use the formula of the kinetic energy that is equal to 1/2 mv squared. So I use the kinetic energy here formula, and I use the kinetic energy there to find the final and initial kinetic energy. And change of the kinetic energy is going to be equal to work, and work is equal to force times the distance. 70-kilogram athlete runs up the stairs from the ground floor to 102nd floor, which has the height of 370 meters. How much potential energy does he have at the top of 102nd floor? So again, the information that is given, the mass of an athlete, 70 kilogram, and the height that he gets onto is 370 meters. And I have to find the potential energy. The potential energy formula is mgh. Potential energy is the energy of the position. If an object has a height, or an object gains the position, raises to a certain height, it will have potential energy, and energy is measured in joules. So if I want to calculate the potential energy that the athlete gains, I have potential energy is equal to the mass, g is acceleration due to gravity, and height is 370 meters. So that number will be, let me get it quickly here, 70 times 370, 259,000 joules. So an athlete had to do a work. So you don't have to find it here, but I just want to show you here. The work is equal to force times the distance. The force that an athlete is applying to raise himself to a certain height is mg, that's the force of gravity, and the distance is h. So you actually found the work that an athlete would do. So the work in this case is also equal to the change of the potential energy. In number 24 is related to number 23, and that's another reason why I found the work over there in number 23. If it took 25 minutes for an athlete to get to the 102nd floor, how much power did he use? So in this case, we have the information that is added, the time. The time is 25 minutes, which is times 60, gives me how many seconds that would be. So that would be 25 times 60. Gives me 1500 seconds. So here I need to find the power. The power is equal to the work an object does over a certain amount of time. So the more powerful an object is, the more work an object can do over the given time. So I'm going to calculate the work, the power the athlete would have to have in order to raise to the height of 370 meters in 25 seconds. So the power in this case is equal to the work. The work is the same as change of the potential energy, and we just found that change of the potential energy because on the ground the object had 0 potential energy. Now the object has 259,000. So that's 259,000 joules of energy an object has, and it took an object 1,500 seconds to do that. And again, I can divide the top and the bottom by 100, and my answer is, and I'm going to divide it by 15, right? Gives me 172.6, and that number repeats, 666 watts. So the power is measured in watts, and the power again is the energy an object can give away or share, or how much work an object can do in a given amount of time. So if somebody can do 1,000 joules of energy in 1 second, that person is way more powerful than the person who can do only 1 joule of energy or work in 1 second. Number 25. 3 kilogram stone is dropped from a height of 100 meters above the ground. What is its velocity when it is 50 meters above the ground, before it hits the ground, and what is the kinetic energy on that height, right before it hits the ground? So what I have is the problem. So it is 100 meters above the ground, and it is 3 kilogram stone. So I'm gonna write right here 3 kilogram stone, 3 kilogram. I'm gonna write with my potential and kinetic energy at the beginning. So the kinetic energy is equal to 1/2 the mass, velocity squared, and the potential energy is equal to mg and h. And in our case, we have 1/2 the mass and velocity squared. So the kinetic energy initial of the object is 0. And the potential energy is the mass, acceleration due to gravity, and the height is 100 meters. So that gives me 3,000 joules. And I'm also gonna write right here something. I'm gonna call it mechanical energy. It's the total energy of the system, and it's not gonna change. So the total energy of the system is the energy of both of them. Through the whole process, the energy of the system is not gonna change. So my total energy of the system, or mechanical energy of the system, is 300 joules. Now I'm gonna look at different heights. So now I have to find what's the potential and kinetic energy of the object and its velocity at 50 meters above the ground. So the potential energy at this height is equal to mgh. The mass is 3, g is 10, acceleration due to gravity, and the height is 50. So it looks like it is 1,500 joules of energy. My kinetic energy and potential energy, no matter where I look, must be equal to total energy of mechanical energy that I have in the system, because the system is closed, nothing is changing in the system. So one type of energy is just going to go from one type of energy to another type of energy. So if I only have 1,500 joules of energy left here, then now the object is moving. Before, the object had 0 energy, kinetic energy, because it wasn't moving, it had velocity equals to 0. Now kinetic energy must be equal to 1,500 joules, because the total energy of the system together still should be equal to 3,000 joules. I also can find the final velocity right here using the formula. My final velocity when an object moves 50 meters is square root of 2AD, right? 2, acceleration due to gravity 10, and the distance it travels is 50. So that is the square root of 1000. And I can take the square root of, not sure which color should I choose, right there. Square root of 100, which gives me 10 square roots of 10 meters per second. So an object falls 50 meters will have this type of velocity. But I also can use kinetic energy to find this velocity. Kinetic energy is equal to 1/2 the mass velocity squared. And in this case, it is 1500 joules. So I have 1/2 the mass velocity squared and equals to 1500 joules. If I times them both by 2, I get 3000 right here. Divide by 3, my velocity squared is going to be equal to 1000. Then velocity at this height is going to be the square root of 1000, which is 10 square roots of 10 meters per second. So I can use kinetic energy formula as well to find this same velocity that I used to use when I was solving for the final velocity. But we haven't solved the question till the end first, because it asks right before it hits the ground, right? I need to find the potential and kinetic energy right before it hits the ground. So right before it hits the ground, it would travel 100 meters. So I could use the final velocity to find the velocity before it hits the ground. That's the square root of 2. Acceleration due to gravity, the distance is 100. So the square root of 2000 meters per second. I can take the square root of 100 and I can break my 20 into 4 and 5, and I can take the square root of 4, so that gives me 20 square roots of 5 meters per second. So when an object hits the ground, it would have the final velocity of 20 square roots of 5 meters per second. But I want to know the potential energy of it. Right before it hits the ground, it doesn't have any height, so your mgh is going to be equal to 0 joules. And my total energy always stays 3000 joules. So if now I only have 0 joules of energy left for potential energy, that means my kinetic energy, all the potential energy went to the kinetic energy and equals to 3000 joules. Because my total energy has to be conserved and stay the same. And that is equal to 1/2 the mass and the velocity squared. So if I was solving this question, I would multiply by 2 both sides and then divide by 3. Or I can divide by 3 first and then multiply by 2. So it looks like my final velocity is equal to, again, 2000, which will give me 20 square roots of 5 meters per second. So you can use energy to find the same velocity that you used to when we were using the final velocity. This question number 26 is about the power. An electric motor lifts an elevator 9 meters in 15 seconds by exerting an upward force of 12,000 newtons. What power does the motor produce in watts and kilowatts? So let's write the information that is given. The height that it's going to lift an object to is 9 meters. The time it takes is 15 seconds, and the force that it applies to do that work is 12,000 newtons. So this is the information that is given. Now, if I have to find the power is equal to the work over the time. Work is always change of energy or force times the distance. So in this case, potential energy is changing because the object is rising. Initial potential energy is 0, and the final potential energy, so the final minus initial, and initial is 0. And the final is going to be the mass, G, H, over the time. So the power in this case is equal to the mass. They don't give me the mass. G and H is not given. Oh, can I use the force times the distance over time as well? Because the work is also force times the distance. So I'm going to use this one. Force is 12,000 newtons. The distance is being raised to 9 meters. And the time is 15 seconds. Looks like I can divide by 3 and by 3. So I will have 12. Instead of 1,000, I'm just going to write 1,000. What's left is 3 and 5. 12 times 3 is 36. And 1,000 divided by 5 is 200. 36 times 200 is 7,200. And measured in watts. Power is measured in watts. Or I can write as 7.2 kilowatts, my answer. And again, power is the work done on the object over a certain amount of time.